coming to the conclusion of the chapter, that is the motion in a straight line. Then after that we'll be starting the next chapter, that is the chapter number 4, motion in a plane. So coming to the conclusion of the chapter, the last topic that we have the topic which is called as a relative velocity. Now based on this relative velocity, what does it suggest? Suppose you are sitting in a bus, and if you see an object outside the bus, like suppose a tree or a car or any person you see, you will be seeing that a person, suppose your bus is moving, you will be seeing that the person that is next to you, that means that is outside the bus, you will be seeing that the person is moving backward and you are moving forward. Okay, the similar way, if I consider that there are parallel tracks, that is a parallel railway tracks, and suppose two trains are moving, and suppose the train in which you are sitting, suppose that train is moving little bit slow, and the other train that is moving on the other parallel track, it is little bit moving fast. You will be seeing that the train has passed you, and your train that where you are sitting, it is moving backward. Why? So this is called as a relative velocity. That means you can compare your velocity with the velocity which is nearby you. This is called as making a comparison. That means a relative. It makes relation between your velocity and the other velocity. Okay. So this is called as a relative velocity. This is just some examples of a relative velocity. Now coming to the relative velocity, if I derive the formula, like we have the relative velocity formula we have. Suppose if I write relative velocity of A with respect to B, relative velocity of A with respect to B, this I write as VA minus VB, relative velocity of A with relative velocity of B. Same way, if I write in this form relative velocity of B with respect to A, B with respect to A, this I write as VB minus of VA. This will be in a form of vector symbol. Okay, this is how the relative velocity formula is done. So this is just, you can see A with respect to B, B with respect to A, or you can use any symbol. You can use PQ or any alphabet you can use. So remember that A with respect to B, it will be VA minus VB, or suppose B with respect to A, it will be VB minus of VA. So this is how the relative formula is done, relative velocity formula. So based on this, if I calculate some special cases are there, like special case number 1. Special case number 1, the case goes like this: when the two objects moves with equal velocity. If two objects move with equal velocity, then what will happen? Suppose in this, suppose VA is equals to VB. Here your velocity are equal. Velocities are equal. Then what will happen to the relative velocity? The value of relative velocity will be equals to 0, because you can see in the formula relative velocity of A with the velocity of B. If I put both the values, so B, since both are equal, so the answer will be 0. Same way, if I consider that second case, case number 2, if I write case number 2, so the case number 2 is when the two objects move with unequal velocities, moves with unequal velocities. Suppose one is considered as, suppose VA is greater than VB. This is a subcase of this. One I will be considering as the reverse one, that is VA is less than VB. So if I consider here, if your relative velocity of A with respect to B, if your A velocity is more, then I can draw a graph in this way. You see, this is suppose your time axis, and this is suppose your velocity axis. So suppose if you consider the speed of the object, because one is moving faster and one is moving slower, it will be in this way. This is will be VA and this will be your VB, because your VB value is going on decreasing. So this will be a graph representing VA greater than VB. Similarly, if I write VA less than VB, then what will be the graph looking like then? This is suppose time, this is your velocity axis, this is just a reverse of this. Your VA also will be going down and your VB will be moving up. So this is your VA and this is your VB. Clear? And if I draw for this one, the first case that we have done, if I draw the graph for this, I am drawing it here. This is your time axis, this is your velocity axis. It will be in this way. VA and VB, they will never intersect each other, because since here the velocity is one is more and one is less, so it will intersect. Here the first one is lesser than the second one, so it will never intersect. Here it will be remaining parallel, here it will intersect, and here it will be never intersecting. It may be intersecting on this side, on the left hand side of the graph. So these are the three cases related with the relative velocity. So this chapter is finished. So we'll be discussing some questions related with this relative velocity in the next class. So after that we'll be starting the new chapter, that is chapter number 4. So this much for today. Thank you.